Alright, there's been some interest in how I run my code for my AI VTubers, so I thought I'd make a little tutorial starting with how I run the API locally. So first and foremost, we have our requirements here. Everything is written in Python, so you can just pip install these. I personally will be using PyCharm for all this, because it is what I'm used to using, and allows you to kind of set up your project with a virtual environment and everything pretty much automatically. If you have your own preferred way of doing things, go ahead and do that. First, we have a FastAPI. That will be how we set up the API and WebSocket that we're using. We have Uvicorn, which we use to run it, and apparently you have to pip install Uvicorn standard to get the WebSocket part to work. I don't know why that is exactly, but if you just do pip install Uvicorn and try to run this, you will get an error telling you, hey, do pip install Uvicorn standard. Then OpenAI, because I use llama.cpp to run my LLMs, and they use the OpenAI endpoint. This code will also work for other ways to run it, such as ollama. You'll just have to set that up instead. And because we are using the OpenAI endpoint, if you have an account set up with them, you can run it through them instead of running your LLM locally. That's entirely up to you, though. And then the WebSocket client we'll be using just to test it out with our little mini app. Depending on what you want to run to actually interact with the AI, you might want something different, but this is what we'll be using for our little demo here. So yeah, once you have all those installed in your library, start with the first part of the code here, which is what we're calling the socket manager. This I actually got from another tutorial, so I won't go too in-depth into this, but it's pretty simple anyway. So we start by importing the WebSocket class from FastAPI.WebSockets. Then we create our own class from that, which we'll call the WebSocket Manager. For the init function, all we're doing is creating an empty list. This is where we will store the apps we have connected to. Basically just putting in the IP address and everything. Then we need a function to connect, which will take in the self as well as a WebSocket, which will be of the type WebSocket. We get the client IP from the WebSocket we're connecting to. It would be the websocket.client.host and the port. We'll go ahead and print that out just to see it. And I'm also printing the headers because you can add custom bits to the header when you're connecting to it, which means that if you have a specific app that you want to send extra data to, even when you're connecting to the AI from a different one, you can tell it that based on the header. Then we have to, of course, await WebSocket.accept and append the WebSocket to our clients list that we created here. Then we will create a message, basically just saying, hey, you're connected, welcome. And we'll send that message back to the client that connected. Then we'll have a little send message function here, which, because I'm not really doing anything special with it, we probably don't actually need. But you can also set up some custom code here if you want to have a more standardized way you're sending out the message. Again, because we're running everything locally, you can, build your own apps and you know what to expect, so you don't really need to worry about it too much. But this does give you the option to customize things a little bit more. And then, of course, we need a way to disconnect, which is pretty simple. We basically just will print out that it's disconnecting just so we can see it ourselves. And we remove the WebSocket from the list of clients. Yeah, this is the first piece we'll need. Then the next piece of the code here is the actual server itself. We have more things we need to import here. Some I'm not using right now but could be useful, such as importing JSON. It's a good chance you'll want async IO and or threading, depending on what all types of functions you want to be calling through the AI. We won't want time, which I'm mostly, in this example, just using to wait while things are going on. With the OS, which is actually just used for if you are actually sending images to your AI model, because there are plenty of open source models that are multimodal, allowing you to input images as well as text. Of course, we have to import FastAPI, so from FastAPI, import FastAPI. And from FastAPI.WebSockets, we need WebSocket and WebSocket disconnect. The base64 is also used if you want to use images. That's just the way you need to send it for llama.cpp specifically. If you're using llama, it might be a different way, I don't actually remember. Again, we need OpenAI for our endpoint. And from the socket manager we just created, we import our WebSocket Manager class. I also have what you will want to type in the command prompt to actually run everything here. Just be unicorn space the name of the file here, which I have is AI server, then colon AI, which will be our FastAPI app we're making here. Then I find that the WebSocket likes to disconnect sometimes if the AI model takes too long to generate its output. So we want to increase the ping timeout. It doesn't have like an infinite, so I just put it to like 10 minutes here. Should be more than enough. But if you find that you don't want to go that high, you can change this up yourself. Okay, so the actual code here. Create our client from the OpenAI. We just need to tell it that it's connecting to localhost 8080. That's what llama.cpp uses by default. Again, if you have a different way you want to run your LLM, you'll need to change this part up. But this works for the default for llama.cpp, which I'm not going to go into exactly today. If there is interest, I can do another tutorial talking more about that later. And we'll want our messages we're sending to the AI. You can have multiple characters and multiple functions if you want. You can name them each. Ideally, you would probably have some default messages in here, which will be each a dictionary, alternating between role user and role assistant, with the content being a string. But again, for this simple example, we're not going to go into all that. Then we have the actual API app. I'm just calling that AI, which is connected to the FastAPI. Then we can create variables that are global for this, because each time you connect to a function here, it will be kind of a different instance, which means that variables within that function, even if they are global variables, will not persist. So if there's anything that you want to persist between sessions, it'll have to be either a variable specific to your FastAPI app, or you can use a JSON file, because again, this is all being run locally. So assuming that you aren't having other people connecting to your AI from external sources, then you will, and of course you're building your own apps and everything, you'll be able to access your own JSON file there, make changes to it from your app, and then read it in your server here. I personally use a combination of both. They each have their advantages and disadvantages. So for this, I just call it AI.waiting. Its purpose is to make sure that the LLM is not being called multiple times at the same time, potentially overloading your system. But you have to be very careful with this, because if something does go wrong while it is generating and you get some sort of error and the function never returns, it won't go back to being false, and if you try to call it again, you're just going to get nothing, which means you'll have to restart the whole server. So again, probably not the absolute best way to do this, but as long as you're careful, it'll work. And again, we need to create an instance of our WebSocket manager we just created. And now the first actual function we have here. So AI.post means that this will work as an HTTP request as well. I will specifically be using WebSockets, which we'll put in a little bit later. But this kind of gives you a fallback, so you can use HTTP as well. I find that WebSocket is better for me because it's a lot faster once it's connected. So it just has to connect to the WebSocket the first time. Then each time you make a call here, you're already connected, whereas HTTP requests, it has to connect each time individually. So it is less likely to break on you. You don't need to worry about like reconnecting and stuff with HTTP requests, but it will be slower. So here, it's calling the function character, because you can make multiple functions in this for different characters if you want, or for doing different things. But again, this is a kind of simple tutorial, so we just have this one function here. So first off, we check to see if we are waiting. Because again, we don't want to make multiple calls to the LLM at the same time, have multiple instances going on there, because since it's all being run locally, you probably don't have that much VRAM available to you. And of course, you can always run it on the CPU rather than the GPU if you don't have enough VRAM, but you still don't want to overload things. Then once that's good, we set the waiting variable to true, so that again, if it gets called again, it will know to wait. This new message bit, we'll get to that in a little bit. It's mostly just here as a catch for if we're putting in an image, which of course will take in a prompt, which will be a string, and potentially an image, which will default to none, because you likely are not using a multimodal model, especially if you don't have enough VRAM for it. And I personally find that they quite often are not as good for conversation. But again, we just have this available here because might as well. We'll set up the context for our character. Again, you probably want a lot more than this, but this is just a simple example here. So we have the role is the system. And our content, just put in, yeah, you're an anime cat girl. Respond in a sweet and cheerful manner. And end your sentences with the nya or other cat sounds. And again, you can create other characters with other functions. You can do a lot more than this. This is a good starting point. Then we have some extra code here in case you do have an image again. So we'll check to make sure that our image we're putting in is a string. And we'll check that it is a path to a file. If so, print up a little message just so we can see that we are properly receiving an image. We'll go down to a function that we'll show off a little bit later. We have to write just to encode the image into the base 64. Then we'll use the new message we created earlier. Have the role will be the user, and content, which would normally just be the prompt, but because we're putting in an image as well, we have two parts here. The text, so we type text, and the text will be the prompt, and type image URL, the image URL being another dictionary here. The URL showing that it is a image base64, and the data we're giving it from the actual image. And again, this is specific to llama.cpp. If you are using another way of interacting with your LLM, you might have to write this differently. But again, this is, if you're not using this at all, you can kind of skip this part anyway. But otherwise, if we don't have an image, we'll just append the character message with a role user content prompt. And then again, we'll just print everything out to see what's going on here. And here we actually send it to the LLM. So we do client.chat.completions.create. I don't know why it has to be this long. Again, this is just how OpenAI's API works. To put in the name of our model, which in this case, I'm just calling model. I believe llama.cpp used to have this as a default alias for all models. I believe they changed it, so you do have to specify that the alias is called this, otherwise you can just put in the actual name of the model here. But I personally find it a lot easier to just give it an alias, so we can use the same thing here regardless of which one we're loading up. And the message will be the context, which is again our system message, plus the character messages, which we've just appended to, and the new message, because again, if we are using an image, then rather than appending all this, so that if we decide to append all this, then it will be sending this extra image data with every input, and will eat up our context length a lot faster. So instead, we're going to kind of keep this separate. Then we will print out our response, which will be completion.choices0.message.content. We'll also set that equal to a new variable here. Then again, because if we had an image, we have not actually appended it to the character messages yet. We'll check again to see if we had an image, and if so, we'll append the prompt to the character message. And afterwards, we append our response, so that now the messages are in the memory of the AI that we have here, so they'll have context of things we've talked about previously. Then I like to go ahead and add all of the prompt and response to a separate file that can be used for memory stuff later on. I personally haven't found a good RAG system that I like for memory. There are a lot of options out there. Probably looking more into it at some point, but for now, I personally don't actually bother with long-term memory. But it is nice to have it here just in case you want it. Then, because we will have limited context length, limited more depending on how much RAM you have available, so we will delete old messages from the character messages once it gets too long. I find that 40 is a good length. That means 20 messages from the user and 20 responses from the AI. So as long as it's longer than that, it will delete the first message. I also tend to put a few starter messages in there before we start actually talking to the AI, just to give them more of an idea of their character and how to respond. In which case, I usually keep those in there and we'll start at the first message that we're actually inputting to the AI, in which case this 0 would be higher. But for this tutorial, this will work. And then again, we need to make sure that we are resetting this AI.waiting back to false. Otherwise, after the first time you call it, it will never return again because it will get stuck here, just waiting for its turn. And then we can just return the text. And again, that will all work as an HTTP request, but here we actually set it up as a WebSocket as well. So AI.WebSocket, and just make the endpoint /ws. And we define our function, which takes in a WebSocket, type WebSocket. And we start by connecting to the WebSocket manager, and then just a while true loop. We need a try except in case it disconnects. What we try to do is take the message. It's a WebSocket.receiveJSON. And then we'll go ahead and print out the prompt just so we can see that we have successfully received it. Then we will expect that our message has a function part, which will be expected to be character for this. Character, again, just being our function here. And again, you can create multiple of these functions, each name different things for different characters, or for other things you want to do with them. There is so much to be done with this code if you want to customize it. Then we will check to see if we are getting an image as well. So again, we'll just check the message keys similar to how we had the function. And if it has image, then the response we're going to get will be, it will send to the character function with the message, a prompt, and the image. Otherwise, we'll just send the prompt because there is no image. Then we will send the response back to the client here, just with a WebSocket.sendJSON, and the message just be the response, which means that you'll, in your app you're building here, you'll look for the message specifically and know that that will be the response. And again, if we get a disconnect error, then we go back to our disconnect function on our socket manager. So then we have the encode image function for if we are using images. We'll take in the image path, which again, because we are running everything locally, will just be a path on your computer. So we can just open that in binary and return base64.base64 encode image file.read.decode UTF-8. And that's all we really need for the server part here. Again, you can add any number of other functions. You can have it connect to a TTS, you can have it connect to VTube Studio, all kinds of stuff. But again, this is just kind of the bare bones basic here. And then finally, we'll go ahead and show a little just test app for how you can actually connect to it. So for this, we'll need to import WebSocket, which is specifically from the requirements, the WebSocket client. There are 2 or 3 different WebSocket libraries in Python, and you may find that you prefer to use a different one, but for this, it is specifically the WebSocket-client. So from that, we import WebSocket. You might want async IO for some extra stuff, but again, not actually going into that here. We'll need to import JSON because, again, the WebSocket expects to take in and return in JSON format. And we use threading just to make a simple way to have a while true loop that we can keep prompting the AI while also being able to run the WebSocket. So first, we need a function for what to do when we receive a message from the WebSocket. We'll take in the WebSocket app. I know it shows is not being used here, but I believe it is needed. I don't know for sure on that. And the message. So when we get what we received here, we'll need to use json.loads on the message, which will turn it into a dictionary. And we will print out the message portion of it, because again, that is what is being returned as the response from the AI. We'll have a little function here to run the WebSocket, just because, again, both this and our while true loop will be blocking, so we need a separate function rather than just having it at the end. Then we'll put together a main function where we will create a new thread to run the WebSocket, and we'll start that thread. Then we'll just have a while true loop, which will take an input for a prompt. We'll put that prompt into a JSON. So we'll use the json.dumps, a little dictionary here, which has the function for the character, which is the function we want to call in our WebSocket, and a prompt being whatever our input is. Then we will send this through our WebSocket app. Then you have a little if name equals main, just a little best practice for how to write Python code. We have our WebSocket app, be websocket.websocketapp, have our localhost 8000, which is the port that the FastAPI will run on by default. If you're already using that, you can set that differently in the server app, and then it'll be the /ws, which is what we set up as the WebSocket. Then on message, we have our on message function we created here. And then I'm also creating a header here, which is not necessary. I just want to show it off that you can add extra bits to this so that you can create functions in your socket manager to, say, look for specific users in case whatever app you're creating here, you want to send things when something specific happens, even if they're not the one that is sending it. It's just, again, extra cool little stuff you can do with this if you want to get creative. And then, of course, we just have to run the main. So that is all the code you really need. I can go ahead and show off how this actually works here. Be back in just a minute with that. Alright. So now, real quick, I want to show off how all this works together. Again, I'm using PyCharm, which is nice because it has this built-in terminal that's already in the correct directory and everything. I have the LLM running separately through llama.cpp, specifically the server. Again, if there's interest in the LLMs I use or the settings I use, I can do a video on that at some point as well. But I'm not going to worry about it too much today. So again, when we're in the command prompt here, we take this little bit that we wrote earlier for our server. We'll just copy and paste that here. And then it should come up pretty quickly because we don't have a whole lot going on. If you have TTS or RAG system or something that's being loaded directly in the server, it will take a bit longer, but for this it won't. See something like this, it will show you the port you're running on here as well, which again we are using in our little app we've made. Yeah, once that's all up and running, go over to our text-to-AI script we wrote. And again, in PyCharm, I can just click the run button here. Otherwise, you'll have to type it out in command prompt and everything. It should come up here. And if we check the terminal, we'll also see that the WebSocket was accepted. And again, we print out the header here because, again, I like to take advantage of the little bit we added at the end here. We see the user, so you can write some script to look for specific users if you need that. Again, we're not doing anything with that right now, so we won't worry about it too much. Now, again, our little app here is not optimized, so it will come up with the prompt for you here before it actually gets everything here. But now we can just type in here, like, hello, how are you doing today? And hit enter. And now it's running here, sending everything to them. And it returns a message to us. She said, yeah, konnichiwa, bounce up and down excitedly, so on. Again, acting like a anime cat girl and stuff. And we can continue talking. So something like, can you tell me a little bit about yourself? And again, jump back over here, where you can't really see everything too well just because the way I have it set up here, but we won't worry about that too much. Yeah, it comes back with another response here about myself, yeah, so on, so on. And again, you can create different characters and stuff. We're doing a very bare bones thing with that. This isn't a tutorial on prompt engineering or anything. This is just about getting things set up. But again, there's so much you can do with this. I personally have multiple games I've built in Godot that connect to a server similar to this to allow the AI to interact with players or play themselves. I have a Twitch bot set up with this to allow for people to talk to the AI and for commands to be done and everything. And counterpoint redeems and such. I have a voice to text that I do through Discord that connects to it. And again, there's so much you can do. But if there's more interest in some of the other stuff I do, I'm more than willing to put out more tutorials like this. The things that would make the most sense, I suppose, are the voice-to-text and the text-to-speech. Though the voice-to-text I'm using, I do it through Discord, and there's currently some slight issues. Everything works, it just is a little suboptimal right now. I'm still waiting on some fixes from the discord.py library. And then as far as text-to-speech goes, so much of it is dependent upon the actual TTS model you want to use. And I am currently looking into a new one, but I have tested out a few different ones and would be willing to do a tutorial on one of those if there's interest. But yeah, if you found any of this helpful or interesting, be sure to give us a like, maybe a follow if you want. And yeah, that's about it for today. Hope you found something here useful, and hope to do some more of this in the future.